In this series of videos, we'll go over pretty much all of the time value of money material covered in a typical introductory finance course. This course is sometimes called Financial Management, sometimes it's called Finance 1 or Introduction to Finance. Depending on the text that you're using, this material is usually covered in either one or two chapters. Let's start with the basics of what you should be able to do once you've gone through the video. First, perhaps the most important thing to learn in this video is when you can use the future value of a lump sum setup. Second, you should be able to calculate the future value of a lump sum. In this video, I've demonstrated how to do this two different ways, using the time value formula and also using a financial calculator. In this case, I've used the BA2 Plus calculator, but using other calculators with finance functions, they'll be largely similar to the setup on the BA2 Plus. Third, you should be able to not only state what the future value of a lump sum formula is, but, and this is even more important, you should be able to explain what those component parts of the formula represent. Next, let's start by looking at a very simple, very basic problem. Let's assume that you put $10,000 in the bank and that it earned a 5% interest rate for 1 year's time. What would you have at the end of the year? The answer, of course, is $10,500. Now that may seem pretty obvious, but let's break things down to see if we can get a little more understanding of how this process works. We'll start by breaking down what we all pretty much know, and then we'll rearrange things a bit. So where did that $10,500 come from? The principal was $10,000. Think of that as 10,000 times 1. The interest was $500, so that would be 10,000 times 0.05. Let's combine these two, the principal and the interest, and rearrange things a bit. So putting those last two statements together, that 10,500 is equal to 10,000 times 1, the principal, plus 10,000 times 0.05, and that's the interest. So taking the 10,000 outside the parentheses and combining these two, we get 10,000 times 1.05. 10,000 times 1 plus 0.05. So here are the important points. This $10,000, the first term on the right-hand side, is called the present value. That represents the money now. The 10,500 would be the future value. And the 1.05 is called the future value interest factor. Think of that as the value that translates this $10,000 present value into a $10,500 future value. Okay, next, let's do that. We've done that using the formula, so let's do this now using the BA2 Plus financial calculator. We're going to solve this problem using what's called the time value worksheet in your calculator. The keys in the time value worksheet are found in the second row of keys from the top. If you haven't set up your calculator yet, take a minute, pause the video, and go to the video series on the BA2 Plus calculator. What you want is the video titled Calculator Settings. This video goes through the settings you need for your calculator to behave. To summarize, I typically set the calculator to 9 decimal places. Now that's the format setting on the bottom row over the decimal key, and to 1 period per year. And that's the P/Y setting. That would be in the third row from the top over the IY key. In general, you'll typically want to start a problem by clearing the worksheet. And to clear the worksheet, you hit the second key, which is on the left-hand side of the second row from the top, followed by the FV key. And that FV key is on the right-hand side of that same row, second row from the top on the right-hand side. What that does is clear the memory in the time value worksheet. And in fact, if you look over the FV key, you'll see lettering that says clear TVM. So you hit the second key, followed by the FV key, and that sets everything in the worksheet to 0. Now we're ready to begin. So here's an important point. We're going to be entering a variety of values into a variety of locations. The order that you enter the inputs doesn't matter. In other words, it doesn't matter whether you enter PV first and then IY, or IY first and then PV. But what does matter is the order of what I call value versus storage. So for example, you would want to give it the value first, the $10,000, that's our value. Then you hit the PV key. That tells the calculator to store the 10,000 in PV. You don't hit PV followed by 10,000. You would hit 10,000 followed by PV. So 10,000 is our present value. 1 is our number of periods. Now in this case, a period is a year, and we have 1 year. 5 is IY. Now one thing to note is that we enter 5% as 5, not as 0.05. So when you're using the time value formula, like we did in the last slide, you enter 5% as 0.05. Here you enter it as 5. And that IY represents the interest rate per period. And you have to be consistent between your interest rate and your period. In this case, we've defined a period as a year, so 5 would be our interest rate per period. And what that interest rate per period is the percentage change in your starting value over 1 period's time. So 10,000 PV, 1 is N, and 5 is IY. Once you've done that, pause the video for a second, enter those into your calculator if you haven't done already, then restart the video, and once you've done that, hit compute, which is on the top row of your calculator on the left hand side, followed by the FV key, and that will give you an answer of 10,500. Now you'll note that the value of 10,500 actually shows up as a negative number, negative 10,500. That's just the way the calculator chip is programmed. But realize that if you're starting with a positive present value, you get a positive future value. But on the calculator, if you put 10,000 as the PV, you'll get negative 10,500 as the FV. If you put a negative 10,000 as the PV, you'll get a positive 10,500. All right, we've done that. A simple problem, 1 year, 5% interest, $10,000, and we end up with 10,500. Next, let's extend things to make things a little bit more interesting. Now let's calculate future value over multiple periods. So what would your investment be worth after 2 years? First, we'll do it using the time value formula. The future value of 10,000 for 2 years at 5%, well, we already know that after 1 year, it's 10,500. So the second year, we'd start with our 10,500, and once again, we'd multiply that times 1.05. Now let's expand that 10,500. 10,500 is equal to 10,000 times 1.05. So this first line is equivalent to the second line. Now let's combine these two terms, the 1.05. So now we have the third line, 10,000 times 1.05 squared. So we have 10,000 times 1.1025. This 1.1025 would be the future value interest factor for 2 years at 5% interest rate per year? And our answer would be $11,025. Let's go back now and see if we can do this same problem using our BA2 Plus calculator. Again, we start by clearing the memory, the second future value combination. Then once we've done that, 10,000 present value. Remember, we give it a value first, then tell it where to store it. 2 is n, that's our number of periods, and 5 is our interest rate per period. Once we've input what we need into PV, N, and IY, compute FV, and we get $11,025. Now, we've done 2 problems, so let's look at the general formula for the future value of a single lump sum. That general formula for the future value is as follows. The future value is equal to the present value times 1 plus the interest rate per period raised to the number of periods. So let's see what these terms represent. The present value is the lump sum value at time 0. In other words, that's the money at the beginning of the period. R is the appropriate interest rate per period. And remember that that R is the percentage change in this PV each period. So whatever you start with, one period, you'll have 1 plus R at the end of that period. So if R was 5% like it was in the last 2 examples, after every period you'll have 105% of what you started with. R is the interest rate per period, and N is the number of periods between the present value, what we started with at the beginning of the period, and the value that we want to calculate at the end of the period. So this is the basic setup. Memorize this, you're going to use it a lot. The future value is equal to the present value times 1 plus R to the N. And this term right here, the 1 plus R to the N, is our future value interest factor. Now, we've seen this formula. Let's see where we can use it. You can use this when, first off, you have a single lump sum now, a single amount now, and you want to calculate an equivalent value at some later date. So you want to translate the value now to a single value at some future time. That's the first characteristic. The second characteristic is that this amount that you have is going to grow at a constant rate each period. Not by a constant amount each period, but by a constant rate each period. So for example, our money is going to grow at 5% each period, 5% a year, or it might grow at 1% each month. 2 characteristics: single lump sum now, single lump sum later, and constant growth rate each period. Next, let's look at where you can use this. The 2 most common examples, you're trying to figure out what an investment would grow to, whether you've invested that in the bank or you've invested money in some kind of risky investment like a share of common stock. You want to know what it'll be worth at some point in the future. Secondly, you could use this for something like population growth. You know how many people there are at a certain point in time, and you want to calculate what that population might be at some point, say 10 years after that. So, this ends the new material for the video. Before we sign out, let's do a quick review. I've listed 4 questions that you should be able to answer. The first 2 are conceptual questions. After you've read them, try and answer them straight up. In other words, try and answer them without referring to your notes and without replaying the video. So once you've read them, pause the video, write down your answers, and then and only then restart the video and we'll go over those solutions. First, write down the general formula for the future value of a single lump sum. Secondly, in that formula, explain what those terms are. When I say explain, what I mean is don't simply say R is the interest rate per period. Try and expand on that a bit. For example, you might say R is the percentage change each period over whatever that period is defined as. So think of it like you're trying to explain these terms to somebody who hasn't seen the video and has no idea about finance or business. So 2 questions. Write down the general formula. Second, explain what the terms are. Next, let's try a problem that's fairly similar to what we already did. You put $500 into an account and you earn 5% annually. What will you have in your account at the end of 10 years' time? Finally, as I said, you can use this setup when you're solving for population type problems. The U.S. population is currently 312 million people. Let's say that population grows at 4% annually. What will the U.S. population be in 20 years' time? So like I said, pause the video, try and answer these questions, and then, once you've done that, restart the video. Now, on to the answers. First problem, general formula for the future value of a single lump sum. Here it is. The future value is equal to the present value times 1 plus R to the n. Let's see what those terms represent. PV is the lump sum at time 0. In other words, it's the amount at the beginning point of this problem. R is the interest or growth rate per period. It could be an interest rate, it could be just the percentage change in that value over each period. And that R has to match up with the number of periods. So if you've defined a period as a year, R would be the interest rate per year. If it's the interest rate per month, then N would be the number of months. FV is the future value, the amount at the end of that time resulting from the combination of PV, R, and N. And this term right here, 1 plus R to the N, is the future value interest factor. Next, the problem. You put $500 in an account, you earn 5% annual interest. What will the balance be in 10 years? First, let's do it with the formula. The future value is the present value, 500, times 1 plus the interest rate, 1.05, raised to the number of periods, and since a period is a year, 10 is the number of periods and 5 is the interest rate per period. So that would be 500 times 1.6289. The 1.6289 is this term here, and that's our future value interest factor. So the future value is $81.44 and 45 cents. Next, let's solve that same problem using the BA2+. 500 is our present value. Don't forget to do the second future value combination to clear the memory. 500 is present value. 10 is N. 5 is IY. And our future value is 81.4445. Now on to the final problem. Our population is currently 312 million. It grows at 4% annually. So what will that population be 20 years from now? 312 times 1.04, 1 plus the interest rate, raised to the 20th power. Our future value factor is 2.1911, multiplied times 312, and we get 683.6304 million people. Next, let's do the same thing with the BA2+. 312 is PV, 20 is N, 4 is IY. Compute future value, 683.6304.